All right, we're going to look at representations of functions as power series today. We've seen previously that a geometric series converges. So if you have some kind of geometric one where the powers keep increasing, we know that a geometric series of r to the n, that the sum of that series equals 1 over 1 minus r. So we're going to use that similarity where our series, instead of r, we got x here for our power series, then that summation should be 1 over 1 minus x. And if we were to write that, the sum of that series out, where our powers keep increasing, it'd be x to the 0 power, anything 0 power is 1. If we put the next whole number in there, which would be 1, it would just be x. 2, we'd get x squared, x third, and so on, added all the way up to infinity. And we know that that would then be, or this series is convergent anytime r is less than 1. And so in this case, or absolute value of r is less than 1. So in this case, when absolute value of x is less than 1, it should be convergent. So that's what we're going to be looking for. What does this look like graphically? So if we keep increasing the number of partial sums, the graph approximation becomes closer and closer to the actual graph. So if this red one here is the actual graph, as we keep using more and more partial sums of this, your approximation keeps getting closer. So if you just use the sum of two terms, it's this black one right here, and it looks a little bit like that red graph right in kind of this area, but outside of that, it's not very good. If we increase the number of terms to, say, 5, we're going to get a better approximation. So if we now use 5 terms instead of 4, now our graph, a little bit further, you can see on each side, maybe from like here to here, now it's a good approximation. If we jump it up to something bigger like 8 terms, okay? So now it's this graph. Well, now you can see from here to maybe about there. Now it's a better one. And finally, there's one more shown on here, this green one that's using 11 terms. Well, now maybe from like here to over there. So every time you add one more on, it keeps getting closer and closer to that red graph. So we can use a power series to approximate maybe a difficult function with a polynomial function, and that's why power series are so important, is that you can, within a range, come up with a polynomial that is very close to some other summation.